Hello students, so in this class we'll be discussing a little bit about your dental calculus. It is a very small topic, let's say around 10 to 15 minutes, but the thing about calculus is every line that I'm telling you has been asked or will be asked, mainly in your INICT exam, right? If you look at the past, even the past 2 to 3 years, multiple questions have come from your calculus. Even in your NEET exam, the most recent NEET exam, 2022, 21, your INICET 2021, right? Multiple questions have been asked from calculus chapter. Okay, that is very small, but every point is being tested, right? So write down. Your main aim is to make notes. There is not much of concept to understand about calculus, right? First and foremost, I will start with what is calculus, or why are we giving so much importance to calculus? All of you should know that your periodontal disease, be it gingivitis or be it periodontitis itself, how is it caused? How is it caused? Is it caused by calculus or is it caused by bacteria, your plaque or whatever? Always, if you get a question, if somebody is testing you on which is the etiology of periodontal disease, be it gingivitis or periodontitis, always the answer will be dental plaque etiology, right? Then, in your third year and final year or internship perio postings, more focus was spent on removing the calculus during scaling. Why do you do so? Why do you pay so much importance or attention to your calculus when it is not the etiology? Etiology, even though it is dental plaque, your calculus is called as the contributing factor. Calculus is called as the contributing factor to your periodontal disease. Contributing factor to periodontal disease. It is not the etiology. Point number one. What you have to know. Understood? What is meant by a contributing factor? Meaning, even though it is not directly causing the disease, it is not the etiology, it is contributing to the periodontal disease by facilitating the etiology. By facilitating the etiology, or it is facilitating the accumulation of plaque. It is facilitating the accumulation of plaque. That is the role of dental calculus. Or in simpler layman's terms, wherever there is calculus present, it is always covered by a layer of plaque. This is a rule. For example, let's say without removing the calculus, you remove the plaque, whatever, impossible, but still manage to remove. Almost immediately, the calculus gets covered by plaque. This calculus has a irregular surface, right, due to which plaque can go and accumulate within the irregularities. It is very difficult to separate the plaque from the calculus. As a general rule, wherever calculus is present or if calculus is present in a particular region, it is almost always covered by a layer of plaque. That is referred to as attached plaque. We'll come to it. It is attached to calculus. Now, your calculus can be divided into supragingival calculus and subgingival calculus. Supragingival calculus meaning which is present above the gingival margin, not the base, which is present above the gingival margin, and subgingival means which is present below the gingival margin. That is the difference between supragingival and subgingival. What is more important is that you should know supragingival calculus it is around hard in consistency, firm to hard in consistency, right? It has a brown, yellowish brown, or it can range from a whitish to yellowish brown in color, right? And it can be easily detached or easily separated from the tooth structure. It can be easily separated from the tooth surface. That is the feature of supragingival calculus. Whereas subgingival calculus, it has been referred to as a flint-like consistency. splint-like consistency, meaning it is much more hard and tenacious. It is very difficult to remove from the or detach from the tooth surface or from the root surface, and it is around green to black in color. If at all you have got the opportunity to see a substantial calculus, it is green to blackish in color. It is adherent tenaciously to the root surface, and it is very difficult to remove the subgingival calculus when compared to the supragingival calculus. Alright, this is the basic difference. Now, how the supragingival calculus forms is, let's say your plaque is present on the surface, on the tooth surface, on the enamel surface. This plaque, it attracts certain inorganic ions, as usual, calcium and phosphorus, which goes and mineralizes. Same with the case of subgingival calculus. But the source of inorganic ions, in supragingival calculus is from your saliva, whereas the source of ions in your subgingival calculus is from your serum or blood. Right? Common sense. If the calculus is present exposed in the mouth, then it draws from saliva mainly. If it is below, it has to get from GCF or from the blood. GCF is nothing but a filtrate of the serum. Alright. So, since the subgingival calculus derives its source of nutrients, that is calcium and phosphorus, from the blood or the serum, it is also known as serum null calculus. It is also known as serum null calculus, since it draws the nutrition from the GCF or the serum. Right. Now, your location of calculus, most commonly, it is present in the mandibular anterior region and in the maxillary posterior region. To be more specific, in the lingual surface of mandibular anteriors and on the facial or the buccal surface of mandibular posterior region. That is because the openings of the salivary gland ducts are present in these regions. Right, parotid gland is present opposite to maxillary molars, and sublingual gland opens and submandibular gland opens lingual to your mandibular incisors. That is the reason maximum calculus accumulation is present there. Okay, your calculus mainly composed of inorganic ions or inorganic compounds. It is mainly composed of, it is hard, so it is mainly composed of inorganic compounds which are crystalline in nature, not just inorganic calcium or phosphate. They are crystalline, they are arranged in the form of crystals. That is the peculiar feature of calculus. Alright, and if I have to describe, there are 4 main crystals that are present in calculus, right? And learn this order that I am teaching you. The 4 main crystals that are found in calculus are your hydroxyapatite, right? Hydroxyapatite. Then it has your magnesium with locite. You have your octacalcium phosphate, and lastly you have brucite. 4 major crystals that are found in calculus. Maximum amount is formed in hydroxyapatite and the least amount is formed in brucite. So again, the 4 crystals are hydroxyapatite, magnesium with locite, octacalcium phosphate, and brucite. Hydroxyapatite is present of about 58% of the calculus. Magnesium with locite is found in the 21%, octacalcium phosphate 12%, and brucite 9%. The least concentration is found of brucite. Okay, maximum is hydroxyapatite. And this also has been asked. Hydroxyapatite is not only found in your enamel and bone, it is also the bulk, main component of your calculus as well. Right? It is also crystalline. Now, your hydroxyapatite and your octacalcium phosphate. The hydroxyapatite and octacalcium phosphate are found most frequently or most predominantly in the mouth. Whereas your brucite is found maximum in the mandibular anterior region. Bruchite is found mainly in the mandibular anterior region, and your magnesium with locite is found posteriorly. I repeat, among the four crystals, hydroxyapatite and octacalcium phosphate are present widely distributed throughout the mouth. Bruchite is found exclusively more predominant in the mandibular anterior region, and magnesium with locite is found more commonly in the posterior teeth. Right. Now, if you compare the composition of subgingival calculus with supragingival calculus, if you compare the composition of subgingival calculus with supragingival calculus, it has the following differences. That is, it has the same hydroxyapatite content. Please write it down, okay? Everything has been asked. It has the same hydroxyapatite content. It has more magnesium with locite content compared to supragingival, more magnesium with locite content than supragingival, and it has less amount of bruchite and octacalcium phosphate. These are the 3 points regarding subgingival calculus. Hydroxyapatite is the same, magnesium with locite is more, whereas octacalcium phosphate and bruchite are found in reduced quantity when compared with the supragingival calculus. This is the feature of subgingival. And again, to continue, if we go subgingivally, as we go subgingivally, the ratio of calcium to phosphate, this calcium to phosphorus ratio, it increases as we go subgingivally. As we go deeper and deeper in the pocket, the calcium to phosphorus ratio is increased. Has been asked. Every line has been asked. Okay. Next, the sodium content. The sodium content also increases subgingivally. Again, has been asked in 2021. Right? This question. The question is framed in such a way to confuse you. That is, all of the following statements are true except. They can ask you sodium content decreases as we go subgingivally. Calcium to phosphate ratio is decreased or increased as we go subgingivally. To answer such questions, and these are the questions that mostly is expected from calculus, you have to know all these points that I'm making you write. All right. Next, right? The difference between subgingival and supragingival should be important. Same hydroxyapatite, more magnesium with locite, and less amount of bruchite and octacalcium phosphate. As we go subgingivally, calcium phosphorus ratio is increased and the sodium content is also increased. To talk about the formation of calculus, it is nothing but mineralized dental plaque. Calculus is nothing but mineralized dental plaque. So we have to talk in respect to the amount of mineralization that is taking place. That is, the mineralization usually begins or usually starts between the 1st and 14th day of plaque formation. That is, within the first to the 2 weeks, between the first and the 2 weeks of plaque formation, the plaque begins to mineralize. That is, the calculus is beginning to form. Your plaque becomes 50% mineralized in 2 days. Your plaque becomes 50% mineralized within 2 days, has been asked in exam. Right? Half of the plaque becomes mineralized in 2 days, whereas the plaque becomes 90% mineralized in 12 days. It becomes 60 to 90% mineralized in 12 days. These values are very critical. Alright? That is, I repeat, it starts to mineralize between the 1st and the 14th day. It becomes 50% mineralized by the 2nd day in 2 days, and it becomes 60 to 90% mineralized by the 12th day, right? Within 12 days. And the calcium concentration in saliva, the calcium concentration in plaque when compared to saliva is 2 to 20 times. higher. When you compare the calcium content in plaque with that present in saliva, it is much more present in calculus. That is, the calcium content is around 2 to 20 times higher in calculus than compared to saliva. So it is a very rich source of calcium. And the next point what you have to write is, in case of heavy calculus formers, meaning, let's say there are a group of people. Some people, if they do not brush, they do not form calculus, whereas some people form calculus very easily. Their plaque becomes very easily mineralized in such patients. In heavy calculus formers, your phosphorus content is much higher than calcium. Phosphorus content is much higher than calcium. That means, what do you infer from this statement? Has been asked again. What is inferred from this statement? That in heavy calculus formers, there is more concentration of phosphorus when compared to calcium. What I mean by this statement is that, write it down, for the formation of calculus, your phosphorus is more important than calcium. Underline. Even though we study calcium as the most important factor for mineralization, for calculus, it is phosphorus. It is more important than calcium. Alright, almost this is found almost in 3 times. Amount of phosphorus is found almost 3 times more than calcium in heavy calculus formers. The last point about calculus, all these are key points, okay, for you to understand. The last point in calculus is average daily increment of calculus. Average daily increment of calculus that is formed is around 0.10% to 0.15% of its dry weight. The average daily increment, meaning if you compare a person's calculus, the weight of calculus today and tomorrow, it has almost increased in 0.10 to 0.15% per day of its dry weight compared to the previous day. Alright, so these are all the important points regarding calculus. I told you it is nothing much to understand. It is all about the written points and mostly values. And I have also told you what kind of questions to expect. They are like, all of the following are features of subgingival calculus except more amount of bruchite. Right? Such questions can come. Also, they can ask you to distinguish between supra and subgingival calculus. And then they have tested and they can test you based upon the key factors that I have mentioned. Right? Like calcium content is important or phosphate content is important. Sodium increases or decreases as we go subgingivally. Right? The calcium to phosphate ratio. All these are frequently tested in your exam. So with this, we come to the end of calculus topic.